Okay, so for this one, the first thing we want to look at is some that are kind of already factored, because before we've just been factoring things, and now we want to solve for when they're zero, which is really honestly why we focus so much on factoring things, is because there are many times in your life that you want to know when something is zero. As of now, it's to find, when something's zero, when a ball hits the ground, or when your break-even point is between, because if you find the profit equation, normally you have to put money out before you can start making money. So when the profit hits zero, that's when you've broken even. Things like that. And then later in life, you want to find when things have a maximum or a minimum, or a change in their concavity, and sketching functions, and solving when things turn around, or all these things that will happen in calculus when you set not the original function equal to zero, but the derivative or the second derivative, and so forth. All that to say, there is value in being able to set something equal to zero and find when it happens, and really you need to be able to factor it so that you can use the fact that, dang it, I keep doing that out of order, so that you can use the fact that, I'll change the pen color, we'll see how that works. Okay, so you use the fact that if A times B times C is zero, there are basically three times when that happens. It's when A is zero, or when B is zero, or when C is zero. Because anything times zero is zero. So if any one of them is zero, then it's zero. But also, if all of them are not zero, then it's not zero. You have to have a zero in there. So a product is equal to zero if and only if at least one of the factors is zero. So to find out what makes it zero, you have to set the pieces equal to zero. So on this first one, we've got b minus 4 times b minus 7. So see, this looks like something you get after you factor. This is already in factored form. So if b minus 4, oh, it changed it back to red, that's annoying, times b minus 7 is 0, then either b minus 4 is 0 or b minus 7 is 0. Either one of these things will make it true. So in this case, adding 4 to both sides, b is 4, and in this one, adding 7 to both sides, b is 7. So the solution to this is b equals 4 or b equals 7. Okay, now we have k minus 8, k plus 2, so if that equals 0, then k minus 8 is 0, or k plus 2 is 0, adding 8, subtracting 2 this time, because we want to get rid of this one. You'll start to notice that once things are factored, it's always changing the sign of these if it's just k. If it's just k minus 8, you're going to add 8, so it's 8. If it's just k plus 2, you're going to subtract 2, so it's negative 2. So once it's factored, this one gives positive 1 because of the minus 1, and negative 7 because of the plus 7. Negative 5 and negative 4 because they're both positive. Okay, now this one, we've got t times t plus 2. So this one actually in a way is easier, but if you're just doing it in your head automatically, sometimes people forget to deal with this one at all. So either t is 0 or t plus 2 is 0. So you get the minus 2, which you probably would have gotten right away, as we've already talked about this, but people forget this one. T equals 0 is a solution because the t is sitting out there. So 0, negative 2. Negative 7, negative 6. The z is sitting out there by itself, so z equals 0 is 1. Positive 6 is the other one. The 2m doesn't actually change anything. So if 2m is 0, then m is 0. Because this basically would be either 2 is 0, or m is 0, or m minus 1 is 0, and 2 isn't 0. So, again, 8 is 0, nope, or s is 0, or, now this one's different, 3s plus 8. So 8s is 0, or 8 is 0, or s is 0. You can write that also. This gives s equals 0 over 8, which is 0. Or you could have said 8 is 0, or s is 0. Or 3s plus 8 is 0. So subtract 8. Because when we're solving for s, we're trying to undo things, right? So you go in the opposite order of PEMDAS, because you're trying to undo things. So I guess sad miss. So first undoing the adding and subtracting, so we're undoing the adding. And then we undo the multiplying. So we get negative 8/3. Okay, so this one, 2 equals 0, or n equals 0, or n equals 2. 6u minus 5, 8u minus 1. Okay, so 6u minus 5 equals 0, or 8u minus 1 equals 0. I'm going to unadd and subtract first. So add 5, add 1, and then unmultiply. So 5/6 or 1/8. Okay, so now let's go over here where we have to actually factor it ourselves. So we have 49v squared plus 5v equals 0. I'm going to see, well, I guess I can try to memorize it, but I'm going to see how it goes for me to try to solve it inside the box here. So we have factoring out of v, because that's the only thing they have in common. So we have 49v plus 5 equals 0. So either v equals 0, because of that v there, or 49v plus 5 equals 0. So I would subtract 5, and then divide by 49. Okay, now this one, because if I have 8 and I get 4, I square that, I don't get 12. It's not a simple, necessarily, factorization. So let me see. Negative 8, 12. I know it was an x, but okay, so if I have this, I come over here, and because this is 1, this is just 12. 1, Well, and because this is positive, they're both going to match. Either both be positive or both be negative. And because this is negative, I need them to be negative. So negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. So negative 13, negative 8, negative 7. I want negative 8. So it's this. So x minus 2, x minus 6. And now I'm back in the previous situation where I can just say the answers are then 2 and 6. Okay, negative 11 plus 24. And by the way, let's say that it had said something like this first. Say plus 15 equals negative 9. Then the first thing I need to do before I start factoring, because there's nothing else in the world that you can say if this product equals this number, then I know something about these numbers. It's just when it's 0. You've got to have 0 on one side so you can say one of the pieces has to be 0. If the result on the other side is 5, it could have been 1 and 5, it could have been negative 1 and negative 5, it could have been 5 halves and 2, you just can't know. So you've got to get 0 on one side. So you would have added plus 9, and then you would have gotten x squared minus 11x plus 24 is 0. And now this is something you can deal with. So you have to have 0 on one side. And of course here we do, but in another problem maybe you don't. And you have to. So leading term of 1, so 24. This is positive, so either they're both positive or both negative. That's negative, so they're both negative. So negative 1 and negative 24, negative 2 and negative 12, negative 3 and negative 8, negative 4, negative 6. So negative 25, negative 14, negative 11, negative 10. I want this one. So I get 3 and 8. 20, 41, 2. Okay, so there's nothing in common to factor out, even though there's that 20 on the side, because 41 is prime. So I take 20 times 2, so 40 is the thing I'm factoring. It's positive, this is positive, so they'll both be positive. Okay, so I need the 41. So 20v squared, rewrite that as v plus 40v. Over here, take these. Oh. So, factoring out the blah, v times blah divided by blah, 2 times blah divided by blah. So minus 2, or minus 1 over 20. 2, 27, 13. Again, there's nothing we can factor out, so we have to come over here. 2 times 13 is 26. This is positive, so we'll do positive ones only. Okay, I think maybe one more of these. We'll wrap this one up and then I'll do the quadratic formula video. So 13, negative 15, 2. 13, negative 15, 2. That was annoying, sorry. So 2 times 13 is 26. That one's positive, so they're either both positive or both negative. This one's negative, so we want negative.
It's an all-acoustic Sirius XM house served exclusively in the Omnibus.
Okay, so these only have x in common. And this one, I need to factor out that minus 1, but that's all they've got. So I factor out 13x minus 2. Now, there's nothing holy about the order I'm doing things in. If you wrote it instead, I'll just come over here, 13x squared minus 13x minus 2x plus 2. Of course, you ran off the page, but okay, so then that's just doing these in the opposite order. Now I'm going to split these instead. So I would take out a 13x, x minus 1, and I take out a minus 2. If there's a minus here, you always want to take it out. Now the thing I factor out is x minus 1. But see, I end up with the same things, just in the opposite order. So if you write them in the opposite order, you'll wind up with them backward. But then you'll still have the same two solutions. And it doesn't matter what order you write them in, so... I don't remember if I said I'd do one more or two more, so I guess I'll do this one and then move on. 3, 40, 13. Okay, so we have 3 times 13. This is positive, so they're both the same. This is positive, so they're both positive. Again, if you don't want to try to decide that, you can list out all the possibilities and add them until you get the right thing. Okay, real quick, because this one is a difference of squares, it's p minus 11, p plus 11, so we'll end up with plus 11 and minus 11. Okay. Alright, I'm going to wrap this video up and then do the quadratic formula last.